Hey guys, how's it going? I'm going to, I'm redoing this video. So those of you who did try to watch it had no sound, I do apologize. But here is the fix up. So I'm going to start off here because this is where the video picked up from. So I'm going to go through the rest of the stuff. Sorry, I'm just pulling something up right now. I thought I already had it up, but I guess I didn't. There we go. Okay, so use your calculator to find the measure of each angle A to the nearest degree. So again, what that means is we need to get A by itself, right? So our focus right here is that guy, right? We need to get him by by ourselves. That means we need to get rid of this cos. Well, how do we get rid of the cos? We need to do the inverse cos. So we're going to do cos to the minus 1, and that means those two cross out. So cos to the minus 1, bracket 0.5736. Okay, so 0.5736. So cos to the minus 1, 0.5736. So 54.99. It does say to the nearest degree, so 55. Awesome. Okay, we're going to do the same over here. So again, we want to solve for A, meaning we have to get that by itself. That means we have to get rid of this guy, which is cos to the minus 1. Okay, so left side, right side. Okay, clear it. So cos to the minus 1, 0.7193, so 44. Okay. So for these next ones, guys, I'm just going to throw in the answer. Please try it. If you are not getting these, you have to ask, okay? Cool. Okay, so finding unknown sides and lengths, so find the measurement of the missing side. So again, this section we are doing cos. When it comes to next week, as I've already stated, guys, I'm not going to tell you which ratio we're using, okay? Oh, pardon me, I did get some coffee to me. So I'm not going to tell you which ratio we're using. So I'm going to show you how to determine which ratio, okay? So again, remember, this is our angle of interest. And we got to figure out what we have. So we know we're dealing with cos, so I'm going to just write it out. Cos theta is equal to adjacent over hypotenuse. So what's my theta? Do I have a theta? Yep, it's 50. So cos 50 is equal to, what's my adjacent? My adjacent's here. And here's my hypotenuse. So my adjacent is x, and my hypotenuse is 35. So, for this one, we are going to use the fish. Okay, we use the fish when we need to solve for a side. Fish is for a side. Okay, so just a reminder, this is over 1. So when we use our fish, we start with the number above or below the unknown letter. Here's the unknown letter, that's my x. So this is it. So I'm going to go up 35 times 50 cos 50 divided by 1. Okay? So x is equal to 35 times cos 50 divided by 1. Right? Because we start here. We go up, which is multiply. We go down, which is divide. So 35 times cos 50 equals 22.49 or 22.5. Again, guys, make sure that you're actually putting this in your calculator, because if you're not getting these answers, you're going to have to ask. Find the measure for k. Here's my k. So I'm going to write out my equation. Cos theta is equal to adjacent over hypotenuse. I'm going to label my sides. This is my adjacent, this is my hypotenuse, and this is my opposite. So it's my theta. There actually isn't a number there, so I'm going to keep it as theta. What's my adjacent? It's 15. What's my hypotenuse? It's 24. Okay, so I'm going to do this guy first. So I'm going to do cos theta is equal to 15 divided by 24. 15 divided by 24. 0.625. Okay, so is the theta by itself? No. How do we get rid of the theta? Inverse cos. So cos to the minus 1 crosses out those two. So I have to do cos to the minus 1 on this side. So cos to the minus 1, 0.625 is 51.3. It does say to the nearest degree, so 51. Cool. So that's it for cos. I'm going to move on to tan. Same idea, guys. Going to go through a few different examples, and then, yeah, we'll be done. So, the tan ratio can also be used to find side lengths and angles in right triangles. In a right triangle, the cosine ratio, I should say tan ratio. Is given by tan A is equal to opposite over adjacent. Okay? So again, guys, always good to start labeling your triangles first, because then when it comes to everything that we are doing, so when it comes to tan A, okay, tan A is that angle, right? So we're dealing it with respect to this angle. So from that angle, we have to find, there we go. We need to find the opposite, and we need to find its adjacent. So what is my opposite with respect to A? It's going to be this guy down here, right? Because it's not touching both those arms. And the adjacent is the one touching its arm. That looks very Christmassy. So what do you notice? There's no hypotenuse. Okay, so when it comes to tan, there's no hypotenuse being used. So just maybe something to keep in the back of your head. So when working with a right triangle and the two sides that are given are opposite and adjacent with respect to the given angle, the tangent ratio is used. So where can we use the tangent ratio? Just like we're doing before. Here's our angle, right? So with tan, so it's tan is equal to opposite. Let's do this again. So tan is equal to opposite over adjacent. So here's our angle. So this means this is my hypotenuse. This is my adjacent. This is my opposite. Okay? So do we have our opposite? Yes. Do we have our adjacent? No. So we can't use this one. Tan is equal to opposite over adjacent. So here's our angle. Here's our adjacent. Here's our opposite. Here's our hypotenuse. Okay, do we have an opposite? Yep. Do we have an adjacent? Yep, right? Because these numbers here. So we can use tan here. Last but not least, here's my hypotenuse. If you're already saying, well, there's a hypotenuse, we don't use it, you're absolutely right. Here's my angle of interest. That means this is my adjacent, and this is my opposite. So opposite, do we have one? Nope. So we can't use this one either. Okay? So again, this is just throwing in some numbers. Tan 28. Again, guys, please make sure you're practicing this. Tan, oops. 0.5317. Tan 36. 0.7265. Okay. Again, now we're using tan A, so we have to find this guy, meaning we need to do tan to the minus 1. So tan to the minus 1, 0.3443. 18.99, so we can say 19 degrees. Okay, over here, same idea. It's going to be A is equal to tan to the minus 1, 2.2460. Okay. Because the tan to the minus 1, cross that out. So, tan to the minus 1, 2.2460, 65.99, so again, we'll run that up to 66. So again, guys, with these ones, I'm going to just throw in the answers. If you get them, fantastic. If you don't, you have to let me know. Because if not, your test tomorrow is going to be really hard. Okay, find the measurement, same idea. We're going to be using tan. We already know that. So I'm going to write out my equation. Is equal to opposite over adjacent. It's with respect to this angle here because it's labeled. Okay, guys? Because we know what that angle is, we're going to use it. So, if that's the case, this is my hypotenuse, this is my opposite, and this is my adjacent. Okay. So, do I have a theta? Yep, 42. Opposite is 46. And my adjacent is x. So, because I'm solving for a side, I need to use my fish. Remember, this is over 1. So I start with the number opposite the letter. So I'm going to go 46 times 1 divided by tan 42 gives me x. So 46 times 1 divided by tan 42. So 46 times 1 is the same thing, divided by tan 42. 51.088. Says the 1 decimal place, so 51.1, because that 8 would round that 0 up to a 1. Cool. Let's do it again. So we're doing tan, so I'm going to do tan theta is equal to opposite over adjacent. Here's my angle of interest, so that means this is my hypotenuse, this is my opposite, and this is my adjacent. Okay, so tan theta, because there's no degree there, my opposite is 19, my adjacent is 8.1. So I'm going to do these two first. (19) divided by 8.1, right? So 2.34567. Ah, look at that. There's no 8, then 9, 0, 1, 2, 3. It's almost like a pattern. So 2.345, that's good enough. Now we need to solve for theta. Remember, our tan is still there, so we need to do tan to the minus 1, inverse tan. Do to one side, we do to the other. So tan to the minus 1. Ooh, did I do that? There we go. I think I was pushing the wrong thing. Tan to the minus 1. 2.345. 66.9. What is it? To the nearest degree. So 67. Okay? So this last one is a real life question that you guys could easily see / you will be getting on your test tomorrow, your assignment, whatever. And yeah, so Elena is building a wheelchair ramp to a deck that is 90 centimeters high. Okay, so this deck is 90 centimeters. So if you think of it, the deck's not very long. If you think of it, you get like 3 30-centimeter rulers, right? So this is a deck. Oops. I know it's not the best deck, but that's okay. Okay. So there's a deck, and so that's 90 centimeters high. The angle between the ramp, there's a lot of mistakes in this note. And the ground must not be greater than 6 degrees. So it can be anything less than 6 degrees, but what we're going to do is we're going to measure out what it would be for 6 degrees. Anything longer, okay, so if we go longer than this, the angle would just get smaller, okay? So that's why we're just going to do the minimum amount. And this isn't anything that you guys could easily do in real life. So let's say if you work in cement or anything like that. Very, very good possibility. So, find the minimum allowable horizontal distance, D, between the start of the ramp and the deck to the nearest 1/10 of a meter. So, we already know we're dealing. So again, we're doing a wheelchair. I'm not going to be able to draw this the best. There's the chair. Okay, so there's my wheelchair. So it needs to be 6 degrees, so then it can go up it. If it were any higher than 6 degrees, the angle of it would be too high, and then the person could, like, if they have to stop, they would, like, go backwards. It just wouldn't be safe. This is standard. There has to be specific degrees for certain wheelchair ramps and stuff like that. Yeah, so you guys, if we know the height of the deck, and we need, because that deck's already been there. Let's say the person got into an accident, the person got old. It's like, well, what's the point of tearing down the entire deck, right? So they can calculate, well, if we need it to be 6 degrees, the distance is what's going to be of importance. So tan theta is equal to opposite over adjacent. We have our degree. Tan 6 is equal to 90 over x, right? This is my adjacent. Hopefully you guys know that by now. Because we're solving for a side, we're going to use our fish. So x is equals to, so it's 90 times 1 divided by tan 6. Okay. Divided by tan 6. 856.2. What does it say? To the nearest meter? So 856 meters. That is long. Think about it. A kilometer is 1,000 meters. So that ramp would be almost a kilometer long. Oh, that's funny. So the ramp must be at least 856 meters long. That's so funny. That is so funny. I might change the question a little bit. Well, actually, if it's higher, then it has to be even longer, so yeah. Anyway, sorry guys. Sorry about that mix-up. But yeah, test tomorrow. Let me know if you need help.